Alrighty. Now, like index laws, logarithms have rules that we can use to actually simplify them without having to do too many calculations. So the first log law we are going to learn about is what happens when we've got two logs with the same base subtracting. So the first log law we're going to look at is what is the log of a of x minus the log a of y? Well, it is going to be the log a of x divided by y. And what does this tell us? Well, it tells us that when we divide two things, we subtract the indices, which is actually something that we already know from our index laws. So let's call this our first log law. In reality, it's usually our second. Doesn't really matter. We're going to be using it as our first. Alrighty, so let's have a look down at this question. So we've got log base 2 of 72 minus log base 2 of 9. So since the bases are the same, we can turn this into division. Base stays the same. Now 72 divided by 9 is just 8. But since we're in log base 2, we should probably write 8, if it's possible, as 2 to the something. Well, since 2 times 2 times 2, 2 to the 3, is equal to 8, we can do that, which means that cancels with that, and we're left with just the answer of 3. Alrighty, so you can see how log laws can be really useful simplifying things that don't look simplifiable. Let's look at another one. So we've got a half log 6 of 81 plus 2 log 6 of 2. So I'm going to introduce two more log laws to you. The first one is the addition rule. You've got log base a of x plus log base a of y. Well, when we did subtraction, it became division, so it makes a lot of sense that when we do addition, it becomes multiplication. Base stays the same, and we multiply x and y together. And the third rule is that if you have log a x to the n, you can actually bring the n outside of the log. And so we're going to be using both of these rules to solve this one. In fact, we're going to use the second rule first, but we're going to do it in inverse. So normally we take the power out, but that doesn't mean we can't do the reverse. So let's write this as log 6, and the half has been pulled out. Now we're going to put it back in, but when it goes back in, it's going to become an indice. And same thing for the other one. So the 2 is going to move back up there. So essentially the 2 is moving into there, and the half is moving into there. But when they move in, they have to become indices. Alrighty. Now this is log 6 of 81 to the half. Well, that's just really root 81. Now, since I know that 81 is a square number, that's going to make that not too bad to work out. And we've got 2 squared. 2 squared is 4. Now we've got log base 6 of 9, which is the square root of 81, plus log base 6 of 4. Using our second log law, we can actually turn this into multiplication. And 9 times 4 is 36. Well, log 36, well, especially in base 6, well, we want to actually write it as 6. So that's 6 squared. The 6's cancel. Well, the log 6 cancels with the 6, and we're left with 2. Alrighty, let's look at one more example. So for this one here, we're going to use just the second rule, actually, the third rule that we've looked at. So let's write this as log 2 of 3 squared over log 2 of 3. Well, using the power law, I can pull the 2 out the front, so I get 2 log of 2 over log 2 of 3. And I'm dividing something that I'm timesing by. So they just cancel and I'm left with 2. And there's our final answer. So those are 3 different questions that look a little bit different, but are all using log laws. Reminder, all 4 of the log laws are on the formula sheet. See you in the next one. Goodbye.